Okay, everybody, we got a very short review here for your test tomorrow. And I'm going to go over the answers to this stuff. Hopefully, you will go over that material yourself tonight. So here we go. I'm going to make this pretty short and sweet. So if you look at the periodic table for number one, it says name the element that contains 11 protons, 11 electrons, and 12 neutrons. And what you're looking at, the element that you're looking for, is sodium. Symbol for sodium is Na. All right. Very simple. You look at this right here, you find that atomic number, that'll tell you what the element is. Number two, an atom with equal numbers of protons and electrons is called what? A neutral atom. Okay. There is no charge to that atom. All right. Number three, an atom with unequal numbers of protons and electrons is called an ion. That's important. Unequal number. If they're the same, there's no charge. It's a neutral atom. A cation is an ion with a positive charge. All right. That means there are fewer electrons than there are protons. It's got a positive charge. An example would be sodium with a 1+ charge. There you go. It's a cation right there. An anion is an ion with a negative charge. Okay. Positive charge for the cation. Negative ion is an anion. And that would be something like oxygen, and we'd say 2- for that one. Okay. Examples for both. Atoms with the same number of protons and electrons but with different numbers of neutrons are called isotopes. The mass is different because different numbers of neutrons, and that is the key. 7. What two particles in the atom are found in the nucleus? Well, that would be protons and neutrons. They make up the mass of the atom. Now, electrons do a little bit too, but they're so small we don't take them into consideration. Where do you find electrons in an atom? They are orbiting the nucleus. You can say the electron cloud, which is outside the nucleus, or orbits, orbitals. A lot of different names we can give it. What scientists believe atoms travel in a fixed orbit around the nucleus like planets do around the sun? That would be Mr. Bohr. Which scientist used the plum pudding model to describe atoms with randomly placed negative particles? That would be Mr. Thomson. Okay. And then, number 11, how many protons in calcium-40? How many neutrons? Well, calcium-40, calcium, first of all, is number 20 on the periodic table. That means there are 20 protons, okay? So to find the number of neutrons, we have to subtract the number of protons from the mass number, and that would be 40 minus 20, which is 20 neutrons. Okay, 20 neutrons. Number 12, if the atom changed, or if an atom changed the number of protons it had, what would happen to that element? It would become a different element. It wouldn't be the same. It would, see, the number of protons determines what that element is going to be. Okay, let's go to the next page, backside. All right. For the following, nuclear notation for lithium, how many protons, neutrons, and electrons are there? Well, if you look at this diagram, we see that this is lithium, of course, says the name right there, plus the symbol Li. Number of protons is that number right there. There are 3 protons, all right? And then how many neutrons? Well, that's 7 minus 3. That would be 4 neutrons. And then number of electrons, that would be 2. 2 electrons. The reason is whoops, this little thing, this little symbol right here says you have one more proton than you have electrons, and that would mean you'd have 2 electrons instead of 3. If they were equal, there would be 3 protons, 3 electrons. That's not the case. There is one more proton than electron. It gives it a positive charge. Okay, gold foil experiment to suggest the protons are located in the nucleus. That's Rutherford. All right. And then, answer the following questions for the following nuclear notation. We have chlorine here. We have an ion of chlorine. And so, let's see. Okay. How many protons? Well, that is going to tell you the number of protons. That would be 17 protons. Electrons. This means there's one more electron than there are protons. That means you're going to have 18 electrons. Okay, it's a negative ion. And how many neutrons? That's 36 minus 17, and that is going to be, what, 19? 19 neutrons, okay? What is the name of the element? Well, it's chlorine. It's a chlorine ion is what it is, okay? Okay, chlorine is 2 isotopes. Chlorine 35 has an actual mass of 34.969 atomic mass units, and chlorine 37 has a mass of 36.9659 atomic mass units. In any sample of chlorine atoms, 75.771% will be chlorine 35 and 24.229% will be chlorine 37. Calculate the average atomic mass of chlorine. Okay, simple. First of all, let's list the atomic mass over here. And then we're going to put, let's see, the percent abundance over here. Okay. Then now we're going to put chlorine 35 here, chlorine 35, chlorine 37. The atomic mass of chlorine 35 is 34.9689. We're going to multiply that by its percent abundance, which is 75.771. And we're going to get for that 2649.62. Okay. For chlorine 37, its atomic mass will be 36.9659. Multiply that by its percent abundance, which is 24.229, and that's going to equal 895.65. 895.65. Then you're going to add those two together, and you're going to get 3545.3535. Let me erase that. That's bad. I don't like that. All right, let me go back to that. 3545.27. And so now we're going to either divide by 100 or move that decimal 2 spots to the left. And if we move the decimal 2 spots to the left, we're going to do this 1, 2. Our number is going to be 35.45. That would be the answer to number 16. Okay. Number 17. Copper is 2 isotopes. Copper 63 has an atomic mass of 62.93 atomic mass units. And copper 65, which has an atomic mass of 64.93 atomic mass units. In any sample of copper atoms, 69.1% will be copper 63. 30.9% will be copper 65. Calculate the average atomic mass of naturally occurring copper. Same procedure. Let's put the atomic mass over here. And we're going to have the percent abundance right here. And then what we're going to do is list the isotopes. We're going to have copper 63 and copper 65. Atomic mass for copper 63 is 62.93. And for copper 65, 64.93. Percent abundance for copper 63, 69.1%. For copper 65, 30.9%. Multiply those together, and what we're going to get for the top number, 4348.4. Just went to the nearest tenth on this one. and the bottom one 2006.3. We're going to add those together. We're going to get 6354.7, and we're going to move that decimal 2 spots to the left or divide by 100, and we do that. We end up with 63.54, and that is exactly what we want. All right. Number 18, for a neutral magnesium atom to become an ion with a +2 charge, what must it do? It must lose 2 electrons. If it does that, it will have a +2 charge. A potassium ion that has 11 protons and 13 electrons has a charge of what? Well, that means there are 13 electrons, there are 11 protons, there are 2 more electrons than protons, and that would be a 2 minus charge, and that makes it an anion. All right. Name the element below. Right there. Let me erase that. See, if you look at that, you look at the number of protons. We don't care about anything else but the number of protons. And if you look at that, there are 9 protons in that nucleus. That is the atomic number. If you look at your periodic table, number 9 is fluorine. And there you go. That's your review. Good luck tonight. Look over this review. Be ready for tomorrow. Charge your computers. That's what your test is going to be on. Have a good night.